Hi everyone. This is another episode on tips and tricks on running backend. So one of the challenge that we normally see in while measuring noise or even signal with a high noise floor is the signal is hidden well below the noise floor. So I'm going to show you some of the tips and tricks on how to reduce the noise floor or the analyzer. So currently I'm connecting to XSA, to be exact, is N9030B Keysight spectrum analyzer, and I have a signal pumping in at 100 meg. So I'm going to turn it on, and you're going to see a harmonics coming out, and you notice there's one hidden harmonics at 300 meg. I just hold on. So what I have set up here, as you can see, this very typical backend setup. So we have a spectrum analyzer in spectrum mode. And one of the tips that I'm going to show you since we are here is to have multiple tabs on top of here, as you can see. So one of its harmonic measurements. I'm going to show you that right after this. And the other one is a normal swept spectrum analysis, and the last one is also swept analysis, but we are able to focus on a certain part of the measurements. I'm going to cover that in a while. So first of all, let's go through here. As you can see, I expect to see a third harmonics somewhere here at marker 3. As you can see, marker 3 I set it at 300 meg, and my center frequency is at 100 meg. So there are a few ways of doing it. One of it is, of course, we turn on the gain or preamp. So we can do it here, or we can just do it here, preamp off, as you can see. So Keysight Spectrum Analyzer has this new features saying it's called two clicks to reach whatever you need. So let's turn it on, and this one out of the way. So as you can see, there's a small spike here, but it's not good enough. So another way to do it is let's change the resolution bandwidth. So resolution bandwidth is like a filter. So when you have a narrow filter, you're actually filtering off the noise floor and you're focusing on that particular signal. So in detail, you can actually engage the local AE, application engineer from Keysight, to have a day training. But so I'm going to go through very fast here. So when you change the resolution bandwidth, let's say from 3 meg to 30K. Oops, too much. So you can see that the noise floor is way below right now. And we can even see the fourth harmonics, which makes sense because prior to that, let's turn this back to auto 3 meg. You can actually see as the noise floor is roughly about minus 88. So once you change that back again to 30K, and you can see that the noise floor has gone down to minus 110. So it's a good increase of your dynamic range. That's why you can see that. But one thing to be aware of is that when you set the resolution bandwidth to narrow, your sweep time will definitely increase. So previously it was right now it's 15.6 at 30K. So if you change back, as you can see, it's 1 millisecond. It's still pretty fast, but if you plan to get a lot of signal, this is something that you have to consider. So that's the first part. Second part, I'm going to show you, these are features that built in our in Keysight spectrum analyzer. So just imagine you have a whole span of signal here. Let's say we increase that span to, oh, sorry. Yeah, because of the center frequency and the DC property here. So we can actually drag this blue square or rectangle to focus on the point that we want to see. So it's dual screen. So these one of the features that are built in Keysight spectrum analyzer. I think it's part of the options that you can purchase as a post-sale upgrade. So it's useful when you have you want to see the whole spectrum of signal and you want to focus on one signal at any given time. So the third thing that I want to show you is this harmonics. So back in the old days, when we do a harmonics measurements, we have to set it up manually. Like for example, if I want to measure up to the 5th harmonics, I have to put on a marker. Let's turn on the marker here. Setting marker 4, normal, and then we set it to 400 meg. And yeah, it's hit and miss because it's a bit deviated, but you got the gist. So you have to have a carrier, 2nd harmonic, 3rd harmonic, 4th harmonic, and so on and so forth. So it's kind of hard, especially when you have to change the center frequency and you have to redo all the marker again, and then you have to do the total harmonic distortion calculation by yourself. So this is an old way of doing it, and this is a new way of doing things. See, as you can see, we just need to set the center frequency. Let's change here. Center frequency, because our transmitter is 100 meg. So once we set the center frequency, you populate up to the 10th harmonics. And then it do the calculations of total harmonics distortion. So this is a very quick way of doing it, and it definitely speed up your measurements results. Then the last thing I want to show you is that, as you can see, back in the old days, in the old spectrum analyzer, wherever you change here, and you probably have to do all the changes in one screen. But in the new spec-end, we are able to have multiple tabs. Let's say you want to create one more tab, so with real-time spec-end, just for the fun of it. And every time you click on the tab, it will be refreshed. And if you want to look at all the tabs in one screen, this is where you can click it. And there's only one screen update at one time, given there's only one hardware connections. So it's very useful when you have multiple different types of measurements and you want to scroll through and see what's going on without changing much of the setup. And best of all, you can actually do this. Go to File, save the setup, state, register. So let's say somebody come back and accidentally change any of your setup, you can actually recall again what you have set up. So this is exactly what you have. And so hopefully this is beneficial. Thanks for watching.